Okay, then. So you've already been told this is a work in progress, and the reason it's a work in progress is because we need to get this calibration step right. Some of the fields we went and we did everything on. So we have the gold standard wet chemistry measurements. We have the scanned of fresh and dried samples. So we have all of the data. Some of the fields we've just got scanned data on dried and fresh, and some we've just got scanned fresh. So what we need to do is build these calibration curves with the estimates of uncertainty and error. And then for a given estate or for the whole cluster, we can then produce a number or produce a map for all of the fields we've scanned. And then, of course, we haven't scanned all the fields. Theoretically, we could do. We could go out and use the scan on all fields. But what we're going to do initially is to build a model. So if we can understand what are the drivers of variation in carbon in terms of land use and management and soil, we can then estimate the carbon on the fields that we haven't measured, but of course they will have more uncertainty associated with them. So we've got these different sets of fields, and to combine them in a single map or to combine them in a single output or report for each of your estates is going to take us, another few weeks to get all the data together in a way that we're confident with. So what I'm going to show you are, again, subsets of the data that you've already seen. And this is what we're aiming for. Okay, we could do it with Marsh Farm for Dammerwick because we've got all data, we've done that uncertainty analysis and the calibration. So you can come up with a mean stock per strata. So the strata is the soil type by land use combination, and each of those will have a mean carbon stock associated with it and an error. So it's expressed as a standard deviation here. So it's how confident you can be in that number. And depending on whether the field was analysed in the lab or just scanned, that standard error will be smaller or larger. And then you can scale up to whatever scale you want in terms of the total carbon stocks that you've got in your different land use types or soil types. So that's what we're going to produce, something similar at the cluster and the estate scale. So what it will allow you to do is to benchmark your estate or your field compared to equivalent land parcels that have similar land use history and similar soil type. So we thought a lot today about the fact that your potential for carbon storage is determined by your soil type. So not all soils are equal. Really, then we need to be comparing ourselves against somebody who's on an equivalent soil to say, well, they're doing proportionally better than me in terms of their carbon stocks. How have they got there and how can I get there? So we're all on a level playing field, if you like, for the headroom of carbon. So these are the kind of data that we will be producing for you. So here they're expressed on those different strata, and these are for just the fields where we have the wet chemistry data. Okay, demonstrating that we are seeing differences, and those differences are scalable and are robust. So you might be able to see differences in the soil series. I haven't got all of them up here because some of the soil series only had a few fields, so it wasn't really worth showing it. And there you can see the difference between the arable and the pasture. So what I think is instructive at this stage is the ranges that we're seeing there. And because this is lab data, okay, we talked about there's a bit of error in the lab data, but most of this variance is real to do with the management and the history of that field. So when I talk about benchmarking, it's saying, well, if I'm on the Aberford soil series, we can put your field or your estate somewhere in this box plot. So I can say, well, compared to all of the other fields on this land use and this soil series in the cluster, this is where I am. I've got 100 tons of, so I don't know why soil scientists express it as megagrams of carbon. It's tons of carbon. Yeah, tons of carbon per hectare in the top 30 centimeters. I've got 100, and my colleague down the road has got, 120. How do we get there? How can I understand where I am and my potential headroom? So this is what we'd expect to see, a lot more carbon in the pasture than the arable. There's no great surprises here, but what it is it's illustrating the kind of data we've got and we'll present you with and the kind of ways you can use it. This is the point that Stefan was making earlier, that a lot of the carbon is in the top, so in the top layer. And so you see less variation between the soil types in the bottom layer as well. But there's clearly an interaction going on here as well. So we need to understand this in the modeling in a way that means we can make sensible predictions. So if you want to improve your carbon on this soil type in this land use, this is your potential for improvement, and these are the potential ways you can do it. And similarly for the difference between the top and the bottom, there's an interaction with land use. So the difference, that concentration of carbon in the top layer compared to the bottom layer appears to be bigger in pasture than arable. And again, it all makes sense. So yeah, so top is 0 to 10 and bottom is 10 to 30. So this is percent carbon. If you express that as stock, obviously you would expect to see big differences between the top and the bottom because there's more stuff there, but this is percent carbon. So again, it's instructive. Yes.
It might be quite interesting to see what the data is between top and bottom.
No. That's exactly the kind of thoughts that hopefully you're thinking now on organic versus conventional versus regenerative. So all of this variance within here, and of course, once we've got all the scanned fields in as well, we'll have all of the fields, and we can start doing some models analysis of what's explaining that variance. And that's where it gets really interesting. You know, we'll write it up as a paper and say, well, I can put myself in as a blob on here. I know where my field or my estate is on here, and understanding the reasons for why you are where you are in that spectrum. Percent carbon by weight, yeah, and that's where the weighing the soils before they go off to the lab comes in, yeah. Yeah, so it's all about these baseline data will be used to benchmark and also to understand the reasons why that box plot is so wide for each land use and the potential to move up it effectively. Okay, so yeah. Oh well, so that line's changed. Isn't that weird? I had a non-linear line on there. Weird. Right. Okay. So ignore the line. You can look at it if you like, but I'd fit in a curve to that. And PowerPoint, in its wisdom, has decided to refit my regression. So this is what we're talking about the contribution of organic carbon to soil health. So what we can start looking at is sense checking these data and saying, are we seeing what we would expect to see? One of the reasons soil organic carbon is good is because it improves the soil structure. You get less of that compacted, tight soil and a more porous, fluffy, aerobic soil with a lower bulk density. So more carbon, lower bulk density, tend to see that more in the pastures than the arable, again, which is what we'd expect. The fact that it's non-linear is important and interesting, but again, we would expect to see that. We can explore that a bit more as the more data comes in. And then this is the point that was mentioned about moisture and water holding capacity. We would expect those soils with higher soil organic carbon to be holding on to more water because they're more porous, more spongy, and we see that as well. So we're demonstrating that we have a range in soil carbon, which we will explain by differences in management, and that range in soil carbon is being reflected in soil structure and soil function, which is all good. Okay, so this is where we want to get to. This is part at the bottom. So this is working with LandApp. Okay, that's better. Yeah. So this is working with LandApp. What LandApp has done for us is they've given us all of those layers on soils and land use. We've then gone out and done our stratified sampling scheme and sampled all your fields. We have got the lab analysis for fields, and then we're now going to infill with the calibration of the sensor and our model. And we are then feeding back the soil carbon data in terms of percent carbon, bulk density, and carbon stocks, which Landat can then map and visualize for you. So this is kind of little patches here and there because we've got incomplete data, but it illustrates for you what we will feed back to you in terms of gradients. You can either express it as percent carbon, you can express it as moisture, you can express it as bulk density, or you can express it as carbon stocks, and you can click through various filters to do that. And because it's graded and it's a heat map, you can see within your estate, we'll do it at the estate level, we can do it at cluster level. You'll be able to see, well, which areas of my farms are doing well in terms of carbon, which are doing less well. And then crucially, as I've noted at the bottom down there, what we will also feed back is some idea of your headroom. So Stefan has been talking about these thresholds for different land uses in terms of that clay soil organic carbon ratio. That will help us to understand what headroom we've got in that particular soil. So you could imagine that you could create another heat map that was illustrative of your potential storage capacity or unused storage capacity, the percent of your tank that is currently empty in that land use or that field. Potentially then you could overlay that with other data layers like combined precision yield maps or your yield data from your farm. And then it starts getting interesting and say, okay, Carbon Quester or Rothamsted or Tim is telling me that this part of my farm has got lots of headroom for carbon storage and it tends to be relatively poor yield. Those two things might not be entirely unrelated in terms of soil health and soil structure, but they're the kind of discussions and conversations we can have once we have these data and these projections. Is that okay? Any questions on any of that?